Okay, so we're doing this question on the assignment that says Sydney draws the triangle OP1, P2, so that means this triangle from O to P1 to P2 and back again. OP1 equals 3, so that means from O to point P1 is 3 centimetres. P1, P2 equals 1 centimetre, so that's from P1 to P2, it's 1 centimetre. And angle OP1, P2 equals 90, so that's the angle from O going through P1 over to P2, so the angle with P1 at the middle is 90 degrees. All of those things are already indicated on the diagram. The diagram is not to scale. They always do that for exam questions so that you don't get answers just from measuring diagrams. Show that OP2 equals root 10 centimetres. So OP2 is the distance from O to P2, and you've got to show that that is the same as the square root of 10. So they've even given you the answer, you've just got to confirm that. So looking at that first triangle alone, you've got a right-angled triangle. So because of Pythagoras, the longest side, which is OP2, from O to P2, that squared is equal to the sum of the other two squares. 3 squared plus 1 squared, which is 9 plus 1, which is 10. So OP2, I should say, must be the square root of 10. So that's how you show that OP2 is square root of 10. So that's quite nice because they've given you the next. So in the last bit we showed that that was square root of 10, and the next bit of the question says Sydney now draws the lines P2 and P3 and OP3, so that's the lines that make this new triangle. Triangle OP2, P3, so that's the big triangle we've now drawn, is mathematically similar to triangle OP1, P2. So they're saying that the big triangle and the small triangle are similar to each other, which means that they are exactly the same shape as each other, but different sizes from each other. Now we know that this side here, OP1, is 3, and this side here, P1, P2 is 1. So this is 3 times as big as that. So that means in the big triangle, this side will be 3 times as big as this side. So we can write that P2, P3, which we're trying to figure out, divided by square root of 10, so that divided by that, because they're similar, it's going to be the same as 1 divided by 3. So the same two sides, when you divide them in the big triangle or the small triangle, gives the same answer. So that divided by that equals that divided by that. The side that we're trying to find out, P2, P3 divided by 10, is the same as 1 divided by root 3. Now because that's an equation, you can do something to both sides, and as long as you do the same thing to both sides, it will still balance. So if I multiply both sides by square root of 10 in that gets rid of the fraction there, and I just get P2, P3 instead of P2, P3 over root 10. But then I've got to multiply the other side by square root of 10 as well, and that gives me, instead of 1 over 3, root 10 over 3. So P2, P3 is the square root of 10 divided by 3. And the question says, write down the length of P2, P3 in the form root A over B, where A and B are whole numbers. And that's exactly what we've just done. We've written it as the square root of a whole number divided by another whole number. Okay, so yes, calculate OP3 is the next part of the question. So it's the next hypotenuse in the second biggest triangle, and we are going to do that with Pythagoras. So just looking at this triangle here, the thing we're trying to find out OP3, because of Pythagoras, that squared is equal to square root of 10 squared, so this side squared, plus square root of 10 over 3 squared. So that's just putting in all of the things we know into Pythagoras, and square root of 10 and squared cancel each other out, so that bit is just 10. Square root of 10 divided by 3 is the same as root 10 squared over 3 squared. You can square separately the top and the bottom. Square root of 10 is squared is just 10. They cancel each other out. And 3 squared is 9. So OP3 squared is 10 plus 10 ninths. Just rub that out. I'm going to write this all as ninths, so I can add them up. So 10 is 90 ninths, plus 10 ninths makes 100 ninths. So OP3 squared is 100 ninths. So OP3 is the square root of 100 ninths. And that can be written as separate square roots, the square root of 100 over the square root of 9, which is the same as 10 over 3.